what do I do? All right, here we go. And with that, all right, let's get started. So again, thank you for coming out to our October meetup. And for the benefit of anybody that watches this later, I'm Jason Klein with Logic Forte, and tonight we'll be talking about continuous integration, continuous deployment through AWS with CodeBuild and CodePipeline. Old slide. All right, here we go. So here's basically what we're going to cover tonight, and this is going to be a little bit more conversational. I'm definitely going to go through a demo and show you a lot of tech, but I already have code samples for all of this out on GitHub. So if you go out to the SGF AWS user on GitHub, you can see all of these repos that we're going to talk about. First off, let's talk about why the CI/CD is so beneficial nowadays. More and more people are coding web apps, mobile apps, front ends, back ends. All of this stuff has to be deployed to servers. Traditionally, way back, you would make changes on a production site, or you would make changes on a testing site, and it would be good enough, and you'd essentially push it up to the production site, and that was sort of the way of making code go live. But nowadays, with things on the cloud and scaling and just a whole different architecture, not like a monolithic project, just tons of moving parts, it makes sense to have a system in place to where you can essentially develop a way to deliver your code. And so that's what we're going to be talking about tonight. But if you think about how many people here have used Git to manage code? Good, everybody. So if you think about every time you make a commit to your Git repo, you're saving a new version of that code, and you can go back to any version at any point in time and see where that code is. Well, with the way these pipelines work, when you're delivering that code to a staging area to test it, or to a production area so that your users or customers can see it, when you commit that code to GitHub or whatever code repository you're using, these pipelines can monitor that storage area, and they'll see as soon as you make a change, and they can, and I'm going to show where we've got this set up to automatically detect a change in GitHub, download the code, build the code, because nowadays most applications have some sort of building process. You have your core source code, and then you run some sort of command to install all of the different third-party packages. Like, let's say you're using a framework like Laravel or Django. With Laravel, you'll run Composer, and it'll download a ton of stuff that you benefit from, but you didn't necessarily have to write. And so that doesn't belong in your code repository. But if you're manually promoting your code to a server, you're having to run that command and wait for it to process, or somehow ship all of those files to the server, and this process eliminates that. So it downloads your source code only, and then it builds the code and runs all of those commands you'd normally have to run for your back end and your front end, and then it can automatically run your suite of unit tests and integration tests and even front end tests, and if everything's passing, can essentially stage it. And if you're willing to trust the system enough, you've built enough safeguards into the system, enough unit tests and things like that, you can even have it go live automatically. I mean, our company has done that, and it's made a world of difference, because now instead of having these huge changes that we promote maybe once every few weeks or once every month, every time we make a little change, it just gets tested and promoted, and then if there is some sort of problem, we know exactly where to look. I mean, if some sort of test fails along the way, we know that it was some of the code that was written today, and we're not having to wonder, well, was it code that was written today or last week or last month? I mean, I don't know about you, but usually after a few days, if I'm looking back at code, I'm relearning the code. So it just really helps out with the development cycle. And so the end goal here is to make it possible for you to push code to production as quickly as possible and as often as possible with high confidence that nothing's going to break. And it took us a while to get to that point, but and it seems like an overwhelming concept if you're not already there, but it is possible, and the grass is definitely greener on the other side. So let's dig in. I guess you'll know how many letters are in my password. I forgot one of my chargers, so. All right, here we go. So that's the end, because we're going to switch over to demo. Let's see, where should we start? We'll start at the beginning. Everyone's probably familiar with the AWS console, so I'm going to flip over to the Git repo that I was referring to, github.com/SGF-AWS, and show you how to navigate some of what we're going to talk about tonight. The main repos that we're going to cover are these top 4. I basically have a blue-green, what I'm going to call a blue-green deployment, which is the code that's actually delivering and building and deploying our Django or Laravel or PHP projects. And then I have separate sample repositories for 3 different projects to show that we can use this exact same system to deliver different projects. So you don't have to redesign the system every single time, though to be fair, as your projects mature, you're going to find that every project has its own needs. Like you might have a back-end project where you're real heavy on API testing, and then you might have a front-end project where you're real heavy on front-end testing. But at the end of the day, they all have the same pattern. I mean, you're downloading source code, you're building it, you're testing it, you're deploying it. So when we talk about blue-green deployment, that the traditional way of building out these pipelines is that you would build it and you would test it, and it would be staged and ready to go to production, and then you would push some sort of button and it'd go out to production, or if it passed all of the tests, you would allow it to automatically flow out to production, but it would get sent to yet another set of servers. When we talk about blue-green deployment, what that means is you essentially have 2 lives. And there's an awesome graphic here that talks about this, so I'm going to pull it up so that you can sort of visualize this here. But essentially, you go through the build process and the testing process, and you end up with something that's staged. And so tonight we'll be talking about containers that are staged and they're ready to go. And then when you flip the switch or push the button or automatically allow it to promote to live, it doesn't get pushed to yet another set of servers. Those staged servers become your production servers. And so in this particular graphic, you can imagine that this orange icon is your load balancer, and then maybe you have a set of blue servers and a set of green servers. And right now, the blue servers are listening on port 80. The green servers are listening on port 8080. But as you hit port 80 on that website, it just keeps bouncing back and forth between the blue server since it's load balanced. But if you were to test on port 8080 or another host name, however you might have it set up, then you would hit those green servers or your staged servers. And when you're ready to deploy, rather than pushing that code from the green servers to the blue servers, the green servers start to accept traffic on port 80. And so you're basically telling the load balancer to just start sending the hot traffic directly to those staged servers. They're good to go. And I'm going to show a fairly simple version of this, but it can get pretty complex to where it's automatically adding in those green servers and monitoring for errors if you have a lot of servers and your application is able to report different stats as far as maybe unusual cache hits or misses or error codes. And if the system were to see too many of those error stats or negative stats, it can stop the promotion and roll back and just leave the blue servers in place and and stop promoting the green servers to live, so that if it's detecting that it's making something worse, it stops the bleeding and you can go back to what's been working and investigate the situation. So that's probably the best case scenario of this setup, is being able to slowly transition those staged servers with that new version of the code into production alongside the old version, and then shut down those old servers to where there's not ever an impact on user experience, not ever an impact on load, especially if you're dealing with a lot of traffic. But today, we're literally just pointing port 80 from the blue servers to the green servers or vice versa. So when I talk about blue-green deployment, that's what we're going to be covering tonight. And this is something that is a modified version of an Amazon example. So you can look at the code that I changed to make this general enough that we can use it with multiple platforms by browsing through I cleaned it up, I made it really nice for you. There's a commit with their code, and then there's a commit with my changes. So it's pretty easy to tell what changed, and the notes explain why. Before we dig into that, I'm going to show you, I'm going to switch over to the AWS console, and I'm going to show you how we would launch something like this. So I guess we'll drill into the blue-green code, and I'll give you an idea of what we're seeing here. They have a main YAML file that is basically an AWS CloudFormation template. How many of you have used CloudFormation? How many have heard of CloudFormation? Okay, so CloudFormation, not a lot of familiarity there. CloudFormation allows you to write code to build out AWS infrastructure. So rather than using the command line and building scripts and things like that, and maybe having a list of your 10 or 20 commands that you're wanting to run to fire up a bunch of different services, you can make a script, and we'll browse through this one just so that you can get an idea of what it looks like. A script that will always have a description, and then parameters, which are user inputs, and then the metadata is grouping these parameters. It just makes them look better when you're inputting the data. And then your actual resources, what you're deploying on Amazon. And I'm not going to go into detail as far as what these are right now. We'll come back to that, but to give you an idea, this particular resource is building out another CloudFormation stack. And it's calling more, so it's calling more templates in here. And so these are grouped in such a way that there's a template that's building out a network in AWS. AWS calls that a VPC. There's another one that's building out the load balancer or the pipeline or the cluster, but by grouping things this way, it's a lot easier to maintain it. Otherwise, a lot like any other code that you work on, if you try to keep everything in one file, it becomes this monstrosity that's impossible to maintain over time. So before we dig into what these look like, let's go ahead and launch this so you can see what happens. I'm going into AWS, and I'm going to my CloudFormation page. Let me get on the right screen here. And this is showing different CloudFormation stacks. Each stack is building out some sort of infrastructure. So let's click on this Laravel RDS stack and see what it's built. It built a database instance called Laravel Demo, and it built out a security group and a subnet group. And that's it. But the beauty of that is you can tell it, let's build out a database, and it asks you a couple questions, and then it churns away at it, and you're not having to remember, well, did I choose this option on this customer's database or that option or whatever, and it makes it super easy to reproduce websites or whatever infrastructure you're dealing with. And just to give you an idea of what that looks like, I'm going to create a stack. I'm going to browse to one of these files, and I'm going to show you what it looks like to build out another Laravel RDS database with this script. It's asking for a stack name, and I usually use the exact same name we use for the template file, so Laravel RDS, but I've already used that name, so I'm going to call it demo. And now you can hard code as much as you'd like into the templates, but these different parameters are allowing us to override settings like how much storage should the server have. It's defaulting to 20 gig, but you can set the server size anywhere between 20 gig and 6 terabytes. It's defaulting to a micro since this is just a little test server, but the drop down allows other options. Since we're using this for a demo and I intend for people to download this and try it out, I purposely don't include a lot of the other options so that they don't accidentally choose some other option and realize that when they went to sleep they were racking up a $5, $10 an hour bill all night. I mean, in comparison, you're talking about pennies per hour with all of these options. And then we're defaulting the database name, the username, the password, and yes, the default is password. Highly recommend you override that. But then you can even choose what network you want that database to live on. And some of these aren't hard-coded and don't have defaults because they don't know what your environment's going to look like. Everyone's Amazon network is different. And now I'm going to flip over to since no one had a lot of experience with CloudFormation, I'm going to flip over to the source code for this just so you can see what this looks like. Hopefully I can zoom in on this. There we go. Too much. So this is the CloudFormation file that we're running, and you can see these parameters. We're asking for the instance class, and in this particular case, it's giving you 3 options. This is a very simplified version. If you start to explore CloudFormation templates, you'll see a much better way of handling these. But for 3 options, this works great. You can see this is pretty simple programming. I mean, if you're familiar with programming, you can look at this. It's just a config file. You can see how we're defaulting to 20 gigabytes of database storage. The minimum value, the maximum value are set, and then when you go to launch it, it uses those parameters to tell if you're in bounds. More parameters, then it goes to set up your actual infrastructure. When we continue, and I'll go ahead and switch over and run this, and then walk through it while it's running. Now it's asking for some options. We're going to skip over those, but I encourage you to learn how to tag all of your resources, especially tagging production versus staging versus testing, so that when you're looking at your billing, you can tell if you have a lot of testing things floating around that didn't get deleted for some reason, or where your spend is happening. People will also tag by customer a lot of times. Because of the way our infrastructure works, that doesn't really make sense for us, but if you're hosting a ton of different projects, one-off stuff for people, and all of a sudden one customer's expenses just explode, it'd be good for you to be able to see that. So your key would be something like customer ID, and your value would be 1234, or whatever their ID is. You could also use domain names or customer names or what have you, but consistency is key here. So you would need to tag the exact same thing everywhere. But like I said, we're going to skip over this, so I'm going to leave that blank and click Next and let it create. And while it's creating that database, let's go back, and I'm just going to browse through here and point out a couple more things in this, and then we're going to move on to the main demo. This is where it's creating the instance, And you can see in this particular case, we're telling it to create a MySQL instance, and we are hard coding a version. And if we switch over and look at something like a Django RDS, and we go down to the exact same thing, we can see that when we're creating the database instance, now we're setting Postgres and a version. So literally, you're just coding the infrastructure that you're launching on Amazon. And then you can define outputs at the end. So when this is done running, and rather than wait for this, I'm going to scroll down to the one that we've already launched. I can click on outputs, and I can see the host name of that server without having to go into the RDS console to look it up. And the benefit of that is if you have nested CloudFormation templates, you can basically return results back upstream to whatever template called the nested template. All right, so now that we've covered, and in this case it's saying that it failed for some reason. Laravel demo already exists. So even though I called the stack something else, there's already a database server with that exact same name. And it's smart enough to know that and detect it and stop and completely back out, and rather than overwriting your infrastructure. So you'll sometimes get frustrated with that early on, but it's well done. And so if we were to go and launch this again, we could we would have to delete the stack, run the stack again, plug in different parameters, and then it would create it. But let's do that with something a little bit more heavy duty. I've downloaded this green-blue code directly to my laptop here, and so I'm going to zoom in for you. And this is a little bit more complex, but because this script is a little bit more complex, they do have a script that you run that asks for some parameters and delivers some things to S3 and then kicks off the CloudFormation template. You could certainly do all of this by hand, but in our case, we're going to go ahead and start this because it takes a while, and then I can walk through one that I've already built while this is running, just so you can see how long it takes and appreciate that it runs on its own and doesn't require our input. So when we go to run this script, you can see the code up above. It's just running a bash shell. It's asking for the S3 bucket name that you'd like to host your templates and scripts on. In this case, I already have some parameters that I'm going to borrow that I've used before, and these shouldn't cause any problems. It's asking for a stack name, SGF AWS, and we'll call this one PHP demo, since I haven't used that name yet. Now it's asking for a GitHub username, and the reason this is important is this is going to automatically tie the pipeline into your GitHub account. So in this particular case, I'm using, I'm going to touch on how this connection happens because it's not super straightforward, and if you've seen it, you'll be fine. I'm logged into a temporary GitHub account. All right, so when you build these integrations to these pipelines, you're basically generating an API key on GitHub, and you're plugging that key into your code, and whatever permissions you give that key are permissions that your code have. Now for this demo, I wasn't comfortable demoing something with like my main GitHub account's API key, so I created a temporary account. But the reason I'm bringing this up is you'll notice this username is SGF-AWS-demo, but I'm telling it SGF-AWS. Okay, so it's a little bit deceiving the way this is asking for a username, but all of the repositories that we're dealing with are under SGF-AWS. So that's really the username it's interested in, because it's using that to build the path to the repository. It doesn't care what your real username is. The point is, when we go to generate that key has access to everything our user has access to. So in this case, SGF AWS is an organization instead of a user. And because this temporary account has full access to that organization, that API key has full access to that organization. So when I tell it username SGF AWS, it interacts with those repositories and doesn't even realize that that's not its username. Once you've generated that key, it's pretty independent of the username.
So you need a key or a username that has access to those repositories.
Yes, and so
reading and write, push, pull.
Not necessarily. It depends on what you're trying to accomplish. In this case, yes, we need administrative rights because to build out these pipelines and build out the automatic integration to GitHub, the AWS is going to use that key to log into your GitHub account and set up webhooks. And what that means is every time some sort of action happens with a repository in your account, GitHub uses what they call a webhook. It basically sends an HTTP request to AWS to notify AWS something happened. Way more efficient than polling, where you would tell AWS every hour or every 5 minutes or whatever, check to see if something's happened. Well, I mean, realistically, with a lot of these repositories, you could go days, weeks, months without anything ever happening. And then you could have like commits happen every few minutes for however long you're working on it. So by setting up these webhooks, you get a lot faster response on your pipelines. And to answer your question, you do need admin access for that. So to set that key up, you would go log into your account. I believe you go to profile, and then, nope, it's under settings. And then you go down to developer settings. It's a little standalone menu at the bottom. And choose personal access tokens. And you can see where I've created, I've named this so that I know what it's for, and I've given it several permissions, specifically the ability to admin repository hooks, and then access to all of my repositories. And if you were to generate a new token, that's going to ask for a password. You can name the token, and then you would click admin repo hook and access to your repos. And it shows, it explains what kind of access you're giving.
You've got to grab the number for it right when you generate it, right?
Correct. And so in this case, I'll generate a temporary one so you can see what that looks like, and then we'll delete it. So it shows you this very briefly, and then when you go away from the page or reload the page, you can no longer see it. You can click to change your settings, but you can't see the code again. So you can generate a new token, or you can delete the token and create a new account. But that's the extent of what you need to do on the GitHub side for all of this to work. So let's keep rolling here. I'm going to plug in that SGF-AWS name, since that's where all of these repos lie.
Hey, I'm sorry, could you go back and on the settings when you're, can you generate a token?
Mm-hmm.
So you want
Repo.
So repo and add.
And then repo hook, administration repo hook. And really repo, for what we're doing, repo is only necessary if they're private repositories. If they're public repositories, like what we're showing here, that's not even necessary. But by clicking that box, if you have private repositories for work or for clients, and you want to be able to automatically deploy them to AWS, you would have to click that, or AWS wouldn't be able to access those private repos. Make sense? All right. And we can come back to that if you have any other questions. Now it's asking for that GitHub token, and I'm going to plug in another temporary token I have, and we'll just keep going. So after that, it's it's prepping some files and uploading them to S3, which is essentially a file server. It's object store on AWS. And then once it's done uploading those files to S3, it's going to kick off the CloudFormation script. And once we see that start, we'll go over to the CloudFormation screen and we can see it working away. Let's see, CloudFormation stacks, and we'll see it working on a new one. So here's the SGF AWS PHP demo, and we're just going to let that ride for a while. But when it's as it progresses, it will end up building out a VPC, and it will end up building out the pipeline right away, but it won't build out the rest of the infrastructure until it detects code in your repository. So it's not going to start to build out servers or anything. When it's done, it's basically built out. Well, let's go ahead and look through it. It's built out a pipeline that is monitoring for code. Let's see what that looks like. So I'm going to Services and CodePipeline. And in our case, we'll see 3 different pipelines. Well, it hasn't built out the third one yet. So we're seeing a Laravel pipeline and a Django pipeline, and I'm building out a generic PHP pipeline right now. So let's look at the Laravel pipeline. It's going to be very simple. All of these are going to be very similar. When you look at this, the main concept behind the pipelines, and we're going to cover this from sort of the 10,000 foot view, because if you understand these concepts, you can apply them to whatever your infrastructure is, whether it be what I'm doing here with GitHub and building code for Docker images for containers and deploying to ECS, or in Tim's case, deploying to Lambda and API gateway. Same concepts. You start with your source code, and this is honestly going to be a little bit more complex than some setups. A lot of times when you're first getting started, you're only going to have one box in your source code piece, and that's going to point to your code repository, whether it be GitHub or the Amazon version, Amazon AWS code commit, or they support a couple other Git type repos. And if we go into that and we look at it, we're going to edit this, and you can see sort of the same view in the editor. Let's just look at our GitHub settings. It's telling us that it's using webhooks to detect changes. We could override that if we didn't have the ability to set up webhooks for some reason, and we could tell it to check periodically. It's a lot slower, but it is an option. And if we were to set up a brand new code pipeline in the web interface, it'll walk us through all of these steps, and it does a pretty good job of that. So the first time you do this, I'd encourage you to walk through those steps to see what it looks like, but then figure out how to code it in CloudFormation, so you're not having to manually set it up or make changes to it anytime you're either duplicating your project or what have you. Because you have to keep in mind, it takes a while to set all of this up. I'm canceling out of this so I can show you we have 2 different projects, this Laravel project and Django project, and I ran the same code to build both of these out. It would have taken literally twice as long to sit there and click all of the options, and that's a lot more error prone if we were doing that by hand. But this source piece is downloading whatever assets you have for your project. And so the main piece here is the GitHub side of things, but then these other 2 pieces are a template file on S3 and a scripts zip file on S3, and they are essentially the same thing that they're named. I can show you what they contain. The template file contains templates, and I thought I already had that open. I'll pull that up on here. So that template file contains these templates, and these are your CloudFormation templates. And then the scripts file contains these scripts. And as we go through this, you'll hopefully get a better feel for why it downloads those separately. CodePipeline. So the important piece here, you're downloading your code. and it's smart enough to be able to monitor GitHub and S3 and notice changes immediately. So even if I were to make a change to a template file and push it to S3, you would see this start to change, and I'll demo that here in a moment. But let's keep going.
Those changes to the templated scripts, those are changes to your environment, essentially.
They can be. Mm-hmm.
I mean, the way you,
Yes.
I mean, it's a YAML for, I mean, you're defining
Correct.
services for
Mm-hmm.
those. Right?
Yeah, let's demo that real quick. So templates, let's say I wanted to, I forget which one it is here. Let's say I wanted to change how much memory is available to a server. So I've already told it to allocate 256 meg to a server, and the reason these are commented out is the commented code is the original code, so that you're not having to look at the diff in the Git repo. But normally I would have just overwritten this. So let's say we want to give it 192 instead. Now, because of the way that deploy was working, I'm having to run those same commands again, but it's using variables. So I'm smart enough to prep them ahead of time. So let's go ahead and push that template file. We're going to zip it. We're going to copy it to S3, and then we're also copying the individual files to S3, but it looks at the zip file. And now, if we sit here and look at this, let me make sure I uploaded. What did I upload it to? Laravel demo. So you'll see it detect a change here in a moment, and this one will start to spin, and it will download the templates, and then it will go through and rebuild your code. And apparently it has detected a change because here a little bit ago, because it's currently in the middle of a build. But while we're waiting on that, let me explain what these next steps are. So essentially, on the build piece is what it sounds like. It's downloaded your source code from GitHub, and if we float over this, an easy way to trace where your code is going. Okay, so it's triggered a source code download, and I guess that triggered a download from everything. But if you float over app, an important thing to understand is your output artifact is called app. And when you go down to build and you look at this first build box, your input artifact is called app. Picture those as connectors between those boxes. So whatever came out of GitHub is going into this build box. And so when this AWS code build is running, it's receiving your GitHub source code. Whereas when this discover piece is running, it's receiving scripts, which is that script zip file, and it essentially puts that out on Lambda. Now, once it's done building, and I've just reset it, so it's going to take 2 or 3 minutes, but once it's done building, it will automatically start deploying. And I mean, when we first started using this, it would go from build to deploy, and our infrastructure was already in place. So it knew this Docker image has been built, and I know how to tell Amazon ECS to use the new Docker image. So our deploy section used to say, notify ECS of the new image, and it would start spinning up new containers with the new image, and as they came up and they were tested, the old containers would get shut down. Now, with the way this demo works, this deploy is a lot more complex. Instead of simply telling existing infrastructure to use the new code, it's building out new infrastructure. That's how you are able to end up with completely separate infrastructure that's staged and ready to go, and then we can push a button and that infrastructure becomes live. And if we dig into that, and let's keep moving, but if we dig into that, you'll see that's where all of these templates come into play, where it's building out your load balancer and your ECS service and the ECS cluster and things like that. And since everyone's infrastructure is a little different, I'm not going to go into a ton of detail on those because we've covered ECS the last month or two. But hit the videos or hit me up if you have questions. With that, you'll see that it's currently building, and then it'll get down to a point where it's deployed, and it's waiting for us to review and approve. I'm going to switch over to a different pipeline since this one is chewing away at that, and see if we have another pipeline that's ready to approve. Okay, so this PHP demo is ready to go. So I'm going to look at the PHP demo pipeline, and everything should be green unless it's, for some reason it's, when I pushed that template deal, I pushed it to an S3 share that all of these are sharing. So all of these are rebuilding right now. But you'll see on this PHP demo, let's show the actual magic here. Let's show that it's alive and well. I'm going to go to, I'm going to flip around a little bit. Have any of you used AWS load balancers before? Okay. The idea behind a load balancer is that you can have all of your outside web traffic hit that server, and then that server forwards it into one or more servers. So even if you only have one internal server, it's a good idea to use a load balancer because you can run all of your traffic through that load balancer, and AWS will handle all of the SSL termination for you, so you don't have to worry about SSL certificates. And it's with your own custom name. It doesn't end up having to be some weird AWS name. And then you can even turn on some security features at that point to screen for different types of attacks, and they handle all of that. And then it gets forwarded into your internal server or servers. I say server or servers because I think it's valuable even if you only have one server hosting a website. And the load balancer can manage traffic for multiple sites. So you don't have to get a separate load balancer for every single site that you're hosting. You could potentially run all of your traffic through one load balancer. So let's look at our load balancer setup. And the reason we're having to look at it is I need to see what the website name is since it's automatically generating all of this and we haven't customized it yet. But we go to EC2 for that, and we scroll down to load balancers, and you should see a different load balancer for each project because the way these templates are set up, they're all generating their own, but you could potentially share a load balancer across multiple projects or websites. Let's look at the demo PHP load balancer. When we look at it, it has two listeners. And these are rules that tell it where to send traffic. So if somebody goes to the load balancer's website address, which is this long, crazy address, and it can be customized to anything you want. But if I go to that address, by default, I'm going to hit port 80. And if you look at the listener rules, you'll see listener port 80 goes to this thing. I mean, this is a target group, but if you don't know what that is, you can click on it and see. Or you could go to port 8080. So let's go and type port 8080 to manually hit that port. And this is a different server. So we're flipping back and forth between two different servers right now. Now, they're using different ports for the demo, but you could easily use something like stage.domain.com versus www.domain.com. And you can, I believe you can even lock down access to certain listeners so that they're only available to your team and not to the world. But the reason I wanted to pull this up is because you can see these are both identical, right? So let's go into GitHub, and I'm going to make a change to the PHP code, so AWS ECS demo PHP, and then we'll see that the change only occurs on one of the sites. I'm going to go and edit the source code. I don't have a copy of this locally, so I'm doing it through GitHub, but that is all right. So we'll go down here, and we're going to add, you can see where it's showing the time on both of these. I'm going to add something right below that. We'll just add a hello world there, and we're going to save this and commit the changes. And it doesn't matter if you committed this locally and pushed it up to GitHub or you committed it live on the repo. The important part is AWS is going to pick up that change. So let's look at our pipeline. And you'll see that 7 minutes ago it pulled some code changes and it's in the middle of a build. And then it also has a deploy that's ready for our review and approval. But now this is turned blue again and it's picking up new changes, and it'll push them down the pipeline just as fast as you can make commits. So you can see that it's already making progress. You can see this build has already succeeded and this one is in progress. As soon as this is done, it's going to start over with the next piece. So you can have teams pushing to that code all day and it'll just keep building, building, building. And you can even add in checks and notifications and such here to where it will, if it is running tests and there is an error, it sends a notification to somebody, ideally even the person that made the code commit, so that they're aware of their problem right away. And then the next change will come through and it'll get built and tested. And the awesome thing about this is it can just keep working away all day. So now it's building those changes. It just picked up the change from app, and it'll sit here and work on this for a little while.
Back up in the first tier.
Yes.
Source tier. What kind of processing happens at that tier, at that level?
Very minimal.
Okay.
At this point, it's probably spinning up some sort of Lambda calls behind the scenes. I don't know what their infrastructure does, but something that's pulling your repo down and saving it as this outbound output artifact. It's saving it in S3 somewhere behind the scenes for you.
But the likelihood of an error at that stage is pretty low.
Correct.
Right. So all it's doing is just pulling in the sources.
Though there could be an error at that stage if something changed with the repo or access changed or something like that. So you'd still want a notification. But you're right. Generally, you're not going to see an error at that point.
Generally, you'll see it down in the build, right?
The build or testing, and this demo doesn't have any real testing built in. Either the build will pass or fail. But we'll wait for this to get down to where the build is complete and deployed, and then when we look at these two sites, one of them will say this one will remain the same, and the one on port 8080, which is essentially your staging site, will say hello world. And when we click the approve button, it'll flip-flop. So your live site will become the staging site until it gets overwritten, and your staging site becomes the live site to recycle that infrastructure rather than completely shutting it off and building it up again next time you have staging. So we'll give that a little bit of time to catch up. And while we're doing that, I'm going to hit on a couple more things because I know we're running out of time, and then I can stick around for questions. But with the way this works, I mentioned when it deploys to staging, you can push this button to approve. That's probably the not the ideal way of handling it. Ideally, you would have a test suite right here, and so after it has deployed to staging, it will run this test suite. And that could be represented by several boxes in parallel, several boxes in a row. So maybe as to finish your unit test before it moves on to your integration test, maybe as to finish both of those before it moves on to user interface tests. But all of those can be set up through this as well. And in some cases, like those user interface tests, I believe it's having to call third parties. I don't think Amazon has a real strong built-in suite for that yet, but it's very well connected, so that's not an issue. If you need to connect into outside services, it can do that.
You guys have a test suite hooked in for your processes?
Most of our code is back-end code, and so we're basically using PHP unit to run a bunch of unit tests and integration tests between a couple different systems once it gets to that point, to make sure that it's able to work with not only the code within that system, but some of the things that are happening between that code base and older code base, to make sure that some of our main functions are still functional. And yes, so I can flip over and show you what that, well, I'll show you afterwards because we're running out of time. But yes, we do use that. And after those tests run and they pass, it automatically promotes the code to live. And that allows us to constantly be running on new features. Let's see, let me look and see if there's anything else here I wanted to hit on before we switch gears. Okay, so that's got one more thing to build, and then that has to run. So while we're waiting on that, let's look at some of the infrastructure behind the scenes. I mentioned we have these 3 different load balancers. If we go to the Laravel load balancer, no huge surprise, we will probably see Laravel. If we go to port 8080, I had sent out a minor change. So you can see the difference between the two. I committed a 5.7 to the test one. And so this will give us an opportunity to demo the push here. Go to CodePipeline, go to the Laravel pipeline, and I'm going to go ahead and approve that change. It's been waiting for approval for 3 hours. Good to go. And now it's going to go ahead and flip-flop those two. So if I refresh staging, it'll take a moment, but live will end up showing 5.7, and staging will end up showing just Laravel. Waiting for it to run still. But that's how it works. Yes, Levi?
So you mentioned how there's this like approval process to switch like which one is staging and which one's production. It just does like a switch.
Right, and that could be automated for this
Right.
demo to keep, because once you start adding all that in, it does make it harder to read.
But my question is there a way to flip-flop it back? Let's say we just like accidentally threw a massive bug into production.
Right.
Is there a way in their UI to...
Not in this demo, but yes, you can build that in.
Cool.
Mm-hmm. Absolutely. Because, okay, so now the live site is showing 5.7, and now the staging site is showing not 5.7. And the reason I show that is a lot of people would expect both of them to show 5.7, but it's literally taking that live site and pushing it back. And so to your point, if you got in a jam, you could add a button in there or some other code somewhere to where you could tell it to flip them again. Absolutely. And then
that staging site, I
Mhm.
guess you could spin it down if you wanted to, right?
you could, but it's running on a container, and what would realistically happen is you would, like I was saying earlier, you would want to start adding the new version, containers with the new version into your production environment and monitoring for problems, and as long as everything's looking good, you start dropping out the old ones, and you would just shut them down. I mean, they're normally, if you're monitoring in that kind of a way and you're not detecting errors, there's not really a real good reason to keep them around. You could certainly go back to that version. It'd be pretty easy to either push that old version to the repo again, or you could even build in functionality to where you could launch a specific version. Before we built out the AWS code pipeline, where you're using another product where it had a drop-down list of all of your commits, and you could send any commit to production. So you could do something like that in here, but you would have to build it out by hand. And there may already be templates out there for that, but I haven't looked. And then I didn't look at the Django one, so I'm going to be brave here and check to see if it's responding. Of course it's not. So there's some issue with the Django code, but for Django people, I'll make sure that that's working. Like I said, I launched it on the way up here, and I just figured it was good to go. But it uses, all of this is based off of the same type of code that we've been looking at the last few months. So let me switch over to that, and I'm going to show you what I'm launching container-wise, and then I'll take questions here. So it's probably hard to see that, but these containers that are out in GitHub, let's see, 2 too many windows. So these three different repos, the main pieces to them are your build spec and your Docker file. With Amazon CodeBuild, CodeBuild uses this build spec to understand what it needs to do to make the build happen. And so really, that's honestly, if you can get this build spec working and you already have the app working in Docker locally, this build spec is the magic sauce to make it work on Amazon. And if for anybody that's already familiar with Docker, I mean, I'll show you the Docker file for Laravel, so you have an idea of what we're talking about. We base it on a PHP 7.1 container. We add some packages. We set up Apache. We handle all of the composer packages, and then we get into Laravel specific things. But at the very end, we do some cleanup with Composer just to try and slim down the size of the container, and then by default, this container launches Apache. So we don't even have to, at the very end, tell it to start Apache. It just knows to do that. And that runs perfectly locally. So this build spec is taking what you would normally build with Docker locally, and it's essentially pinging Amazon's version of Docker registry where you would store all of your container images. They call it ECR. It's pinging that to get some login credentials. And then the rest of this is really, well, I'll go through these a couple sections here. We're grabbing essentially the git commit hash, so that when we're uploading the image to AWS, we're tagging it with the git hash. That way, when we're looking at all of those images, we know this image was this commit in GitHub. And so if you look at ECS and you go to your repositories, you'll have the repository, and they have crazy names for them, so I'm not going to be able to tell which one's which. But you can see these image tags are the git commits. So that's how it keeps track of your different images. And in this case, whichever one this is, it has 4 git commits. But it's pulling that information and saving it. And then with Laravel, we don't store any credentials in the Git repository. You don't want to store your MySQL username and your MySQL password, or your Elasticache credentials if it's secured. And so we store those in a .env file, and we upload that to a locked down S3 bucket on Amazon. And when this is building, it knows where to get that file, and it downloads it, and then it tacks on the git commit version just so that we have access to it from our app. But that's what's happening in the pre-build, and then it runs a normal Docker build, and it tags it with that git hash from the git commit, and then it pushes it with Docker push. It's saying Docker push this commit, and it gets pushed to ECR. So if you can handle that, you'll notice that all 3 of these, the Django one and the PHP one, are all basically the same thing. They have a Docker file that's a little bit different, and then they have this build spec file that's almost identical. In the case of Django, we do the same kind of thing where we store all of our settings in a .env file, and there's like a .env extension or something for Django that reads this, but we're storing that in a bucket, and it downloads it, and then it merges it in with all of the source code so that we can give people access to the source code. And more importantly, we can have a different .env file for production versus testing versus staging versus whatever. And in this particular case, it's basically downloading the production version, and that gives it access to the production database and any of the other production infrastructure. And we've talked about ECS in some prior meetings, so if you have questions about that, hit me up afterwards. That's probably about all I've got for now. You can see while we were waiting on this, the PHP demo ended up building everything out. We already looked at it, and for whatever reason, that change never made it up. But let's deploy and see if that makes a difference. Normally I would have expected it to show hello world right here, so I have a feeling that something got overwritten when we were running all of these different builds at the same time. But I'll check into that and make sure there isn't an issue with the demo code before you spend a lot of time with it. Any other questions? I mean, I know it's a lot of info to digest, but I'm glad to answer questions through the Slack channel afterwards. So as you look at this in the coming days or weeks or months, if you do get stuck on something, reach out.
In the web devs repository right now in GitHub. So
these are in the SGF AWS repo.
So you don't have any YAML files or Docker files in here?
Yeah, sure. So,
were they in here?
So if you look at like this Laravel one is tested and working well.
Oh, good. So those, we could go see.
And you can see the build spec, and you can see the Docker file, and then this is just a bare bones Laravel install. And I'll make sure that these, I know the PHP one is working. I'll make sure that I work out whatever issues going on with the Django one. But my intention is, you could drop in any three of these with this blue-green code, and I'll show you a trick there. By default, it's assuming that you're trying to launch the demo PHP. So if you want to switch to a different project, you go into your stack and you tell it, like I'm going to click on the stack I already built, and I'm going to click Update Stack, and next to get to my parameter screen. I can go in, once a stack is built, I can go in and tell it, no, I actually want this stack to run Laravel, and it'll download that Laravel repo instead. So if you're wanting to use that blue-green code to experiment with those three different platforms, the intention is you should be able to run any of the three. And that same stack can run all of them. Any other questions? Yep.
What's the pricing structure for CodeBuild and CodePipeline?
Super inexpensive. Like I know there's a fee, but yeah.
Is it just like a flat rate?
No, it's a pay per minute or per hour type of fee, just like all of their other stuff. To where if you were building a lot and your builds were taking a long time, it could add up. But it's been very minimal cost for us.
I don't think the pipeline itself costs anything.
But CodeBuild does, because it spins up a resource.
Yes, yeah.
Mm-hmm. I was gonna pull it up just to give you an example, but yeah, Tim's right. The code pipeline, I don't think there is a fee, but if you were using code commit to store your code, you would have a minor fee for that. If you're using CodeBuild to build code, it's essentially spinning up a little EC2 or something, and it's pulling that code in, and then it's running your composer stuff or your YAML stuff, or I mean your yarn stuff, or whatever it is you're needing to do, and then as soon as it's done building, it spins that down. But you pay for whatever CPU usage is happening. And their model, they have 3 different sizes. So you either choose the 3 gig version, the 7 gig version, or the 15 gig version, depending on the size of your project. We've always used the smallest one, and they're charging half a cent a minute. And most of our builds take a couple minutes. So every time it builds, it's charging us another cent. I mean, for what it is, it's amazing how inexpensive it is. So, great question though. But there aren't any flat rates. Everything that we've talked about tonight is pay for what you use. It's not pay by the month or pay by the day or anything like that. It's literally pay per hit or pay per hour, even the load balancers and stuff. So you could spin up the stack and check it out for a couple hours and spin it down and have a couple hours of usage, and it probably wouldn't add up to more than 5 or 10 cents. Yeah, it's all of this is very inexpensive. Great question though. Anything else? If not, appreciate everybody coming out.
Hopefully we get more folks next month. I would definitely like to see more people coming out, but I know that the weather could have been a factor. If you have other ideas, let me know though.
Well, thanks for pulling all that together.
No problem.
I definitely say it was the weather.
I hope so.